Hello and welcome to Add-on. So here's a question for you all. Have you ever wondered why some atomic nuclei are more stable than others? It's like they've got some kind of magic protection, right? Well, in nuclear physics, we call these numbers as magic numbers. But what does that mean and why do they matter? So let's understand that. So first of all, let's picture the nucleus. So let me draw one for you. So here is our atom and this is our nucleus, the tiny core at the center of every atom. So inside it we have got proton and the neutron all squeezed tightly together. So think of it like a crowded concert hall and everyone is trying to stay close but not too close in order to avoid pushing each other away, right? So here it's the proton that causes the tension. Since they are positively charged, they naturally repel each other. This is where the concept of stability comes in. If there is an imbalance in the number of protons and neutrons, the nucleus gets unstable and might even fall apart. Right? So here's a question for you. What do you think happens if we get just the right or the perfect number of protons and neutrons? Well, that's where our magic numbers comes in. So magic numbers are specific numbers of protons or neutrons that make a nucleus particularly stable. These magic numbers are like a perfect sitting arrangement in our concert example, where everyone, the proton and the neutron, finds their place and the nucleus just clicks. So for protons, these magic numbers are 2, 8, 20, 50, and 82. And for neutrons, they are 2, 8, 20, 50, 82, and even 126. Now, what makes this nuclei with the magic numbers so stable? Well, they're kind of locked in by strong binding energy. Now, what is binding energy? Think of binding energy as the glue that holds everything together inside the nucleus. When you hit a magic number, the glue is extra strong and it takes a lot of energy to knock things loose. So compared to other nuclei, those with the magic numbers of protons and neutrons have higher binding energy and therefore greater stability. Alright, so a quick question. Why do you think nature would prefer just magic numbers? Is it like just a coincidence? Well, actually not. It's not a coincidence. Magic numbers come from something called as nuclear shell structure. Just like electrons in atoms are arranged in shells, protons and neutrons also settle into layers of shell within the nucleus. So, and this shell can only hold a certain number of particles. When a shell is completely filled, it's like closing a door. Like in our example of concert room, we are closing the door of that concert. Now, the nucleus becomes much more stable when they have higher binding energy, right? So when a shell is filled, we hit a magic number, making the nucleus stronger. These filled shells act like a protective layer, helping the nucleus resist from breaking apart. So, and that's why elements with these numbers of protons and neutrons are particularly stable. So to sum it up, magic numbers in nuclear physics are specific numbers of protons and neutrons, like 2, 8, 20, 50, 82, and so on, that makes the nucleus extra stable. So these nuclei have higher binding energy and a filled shell structure, which makes them tougher to break apart, right? So now you know about the magic numbers. So next time you think about elements and their stability, remember those numbers. Who knows, maybe you will start spotting patterns in the periodic table too. So what other mysteries do you think might be hidden in the nucleus of an atom? Let me know. Thanks for watching and see you next time for more nuclear magic.